All right, new day and another laptop that needs to be saved. And this time we have an XPS 17. This is the 9720. So this would be like a 2022 model or something like that. This customer sent this in because they said they were upgrading the SSD. And then after they put it back together, the laptop wouldn't turn on. All it will do is like flash an orange light or something like that. So I haven't looked at it yet. Let's look at it together and see if we can get this figured out. All right, the first thing is, does it turn on? All right, press the power button. Nothing happens. I don't see a keyboard light or anything like that. Oh, so I'm press the power button and you can see it flash here whenever I momentarily press this, okay? And it's kind of orange, it's kind of white. It's almost like both lights are on at the same time. Under the camera, I think it might be showing it more as white, but what I'm seeing is kind of like a off-white orange color. But the way that this LED is usually like a full white or full orange. All right, so let's plug in the charger and see what we get here. So we'll look at the meter. And it negotiates to 20 volts, you see. So, but it's pulling 0.14 amps. So that's not correct. On a system like this, it could go up to as much as 0.1 for a second, and then it will drop back down and usually go to 0.02, something like that, or even 0. But let's go ahead and see what happens when we press the power button. So we get nothing happening when we press the power button. All right, so let's go ahead and open this up and take a closer look inside. When people are changing out parts, especially in these types of machines where it has this big bottom cover on it, these covers are really hard to get off. And so a lot of times they stick pry tools in and they break components off the edge somewhere. And so that's kind of what I'm thinking is going to be wrong with this system. They just opened it up to change the hard drive out or to upgrade the SSD or add an SSD or something like that. And so we're going to have to get under the microscope and we'll look around to see if we can see any damage, because that's what I'm thinking. We probably have a ripped chip that's been ripped off the board or something like that. When we have that constant current draw, it's like it's trying to start up, but it can't start up all the way. So these doors are very hard to get off. There's like, it's pretty, like there's just a little crack you got to shove this tool into. And if you don't know what you're doing, you're just shoving tools everywhere. Let me see if there's any pry marks in weird spots, because sometimes you'll see pry marks in the back, because if they don't know how to open it up. And I don't see a lot of marring or anything on the edge here. But so what I'm going to do is I'm just going to get my fingernail in this little slit here, and then I'm going to put my scribe in there, and then we'll just slide across. There we go. And we got the cover to start popping. And we're not letting this go in very deep. We're just getting the very tip to go in, because the motherboard goes all the way to the edge. All right, and the bottom is off. All right, got the main battery here. 2 hard drives go here. This one does not feel like it has a hard drive underneath it. SSD, these are NVMe's. And then we got 2 fans. This is a huge heatsink, and then we've got the sticks of memory right here. So a lot of times what I was saying is that when they stick the pry tools in here, you see how the motherboard goes all the way to the edge. It's very easy for a tool to get stuck underneath one of these boards and then rip a chip off. So that's kind of where we're going to look. But we're going to start with a CMOS reset. We're just going to unplug the main battery, hold down the power button, and see if we can reset the system and see if it does anything different. So I got the battery unplugged. I'm going to hold down the power button. Power button is held down, so that should clear everything. So now when I plug in our power meter, let's take a look at see what the current draw is. So we have the exact same current draw, light coming on the same way. So we know that it's not a CMOS issue, so it's probably not a firmware issue. It's probably going to be something to do with some sort of damage on the board. And so I think the next plan of action would be, let's remove this. I'll take the battery out of here. We'll take these hard drives out. And then we're going to try to look around real quick with the microscope and see if we can see anything obvious. Yeah, one thing is that this battery installs over these hard drive coolers, and so the person would have had to remove the battery too. But that's the only thing extra that they would have had to do. There's not much to putting a hard drive in here, or an SSD. All right, so these are just the coolers. Here's the hard drive itself. It was not even plugged in, but maybe I kind of knocked it out. It was just kind of dangling there, but maybe I knocked it out whenever I was pulling that off. Well, actually, I'm just going to plug in the power again and see if we see anything different now that I have the hard drive out. 0.14, still sitting there. This light's coming on, so that's all the same. And we'll go under the microscope now. Let's take a look. All right, so we see a little dent on this. I'm not sure what this is on there. This could just be the goo on there. Okay, so let's keep looking around. So I don't know if they were adding a second hard drive to this area over here on this side, or if they were just replacing the existing hard drive they have. Here's the power management controller. So this thing handles all the input MOSFETs and the charging of the battery and things like that. So here's the hard drive that we removed. It was on this side. The connector looks okay. But what I want to see is if there's any chips that have been ripped off in here when they were installing the SSD. What about over here? Nothing obvious. Okay, here's the edge of the board where they might be prying. Not seeing anything there. The fan connector. This is the audio board. Okay, that side looks fine. Let's go to the other side. Here's the fan. There is a strip screw right here. So did they take the motherboard out at some point? See, it's like we're detectives trying to figure this out. What's this? That has nothing plugged into it. I'm not sure what that is. I can't remember if there's something that's supposed to be plugged in there or not. That might be an option on this machine that it's not using. So sometimes I do that. So I'll have to look up what that is for. There's the other SSD slot. And this looks okay. Yeah, I'm not seeing any obvious like scrapes from a screwdriver or something like that. So that means the next step is we're gonna have to remove this motherboard because I can't see anything on this side. And a lot of times the pry marks, the screwdriver will go underneath the side here, so I have to pull the board out. So let's do that next. Yeah, I'm wondering why that screw is all stripped because they don't really need to take this fan out or anything. So unless this went to another shop and somebody was looking at it, I don't see why they would have stripped that fan out, that fan screw. I was able to get the screw out though, at least. Okay, so we do have evidence of prying. I just saw it. Let's see if we can get a good shot of this. I might put it under the microscope, but right here, I want you to look down in here into the fans, into this heatsink. Right here, that one looks fine. This one has some dents on the bottom. Let's see if I can do it under the microscope. All right, so here's what I'm looking at here. So if you look at, this is the heatsink, you see a dent here, you see a dent there. There's some prying going on. This side looks okay. So someone was prying from the back. So I guarantee that they were prying in from all different sides trying to get this bottom off. And so we're probably gonna have a ripped chip somewhere. So that's why we're looking for clues, because we don't know, exactly what would be this cause, but, cause and effect. Somebody opened it up, they put it back together, it's not working. And there's a known issue where people are trying to pry this thing open. So let's get this board out and we'll continue. Okay, we got the heatsink off. You should really only open up the laptop with a plastic scribe like this, and you should only be trying to slide in just a little bit. I understand it starts getting hard to get these bottoms off sometimes, especially if you've never opened one. And it's even hard for me to open it sometimes. I cut my fingers up, but that's probably what's happened here. Okay, so we got the board out. Let's take a look around on the other side of the board. This side's the more likely side because right here on this edge, it's easier for the tools to get underneath it. So let's get under the microscope and we'll take a look around. So I have seen in the past, I've seen these chips ripped off in this area. I'm not seeing that right here on this one. We're just going to go all the way around the edge here. I am surprised that I didn't see anything. Let's pull this sticker off, this tape off. Okay, nothing on that side. Okay, all this looks good. And this is a momentary switch. I never really, I don't know, they put these on some of these boards and I'm not sure what it is. It's a momentary switch, so it's not like an on-off switch, or it's not like, sometimes they have them where there's switches to turn off the battery, so you don't have to unplug the battery to like change a screen or change things like that. But I don't know why they put that momentary switch on there. We could probably look it up and figure it out, but that's not what we're doing right now. All right, so I don't see anything on that side. Let's look in the middle. Let's see if we see any blown components or broken things like that. I guess they still could have shorted out something that burned out something. Okay, that looks clear. We'll flip it back over and we'll do another pass on this side, but now that we have the heatsink off, we can see a little bit more. So here's the LCD connector. So we had prying going on the heatsink on either side of this, so we want to look around here too. LCD connector looks fine. These are the power stages for the CPU. That's that power management chip again. All right, here's the edge of the board on the top. Do not see any ripped components so far. That looks like coffee or something, but I don't know. All right, here's the power stages for the GPU. This is probably for the VRAM. It's a wireless card. And you notice this is the same circuit that's on the other side of the board. They have it on both sides, 3-volt and 5-volt power rails. Under here is probably the Thunderbolt controllers, which are shielded and protected, so I don't see that as being an issue. Okay, so we don't see a ripped component. So are we ruling out ripped component? Possibly, because I don't see one. I think what I want to do next is actually, we'll get it under the thermal camera and we'll see what's pulling that 14 or 140 milliamps. So that would be the next thing. All right, I got my thermal camera turned on. I have it mounted right here. It's a Flare1 Pro. I have it hooked to my cell phone over here. So what we're looking for here, since we have a 140 milliamps being drawn, whenever we plug in the charger, something's going to get warm. We don't know what it's going to be. It might just be the power management controller. It may just be the PD controller. But like I said, it's not supposed to be pulling that amount of current. It should be pulling a lot less when it's at idle. So we're going to plug that in now and see what happens. We're at 15 milliamps. Is that heat? That sure is heat right there. Okay, we got something getting really hot right here. Well, 116 is not super hot, but it's definitely hot right there. Okay, but I'm going to look around and see if there's anything else. That probably is our component that is going to be taking all that current. But we're going to look around other places. The CPU and GPU aren't getting hot. so that's nothing to worry about. So everything else looks okay. And on this side, we probably will have these a little warm if it's turning on to 3 volt or something like that. All right, so that's gonna be where we're going, is right here. And so let's pry this open and take a look at that. Here, this area. Okay, so let's take the sticker back off. So what is this? Is it this? Oh no. That's the EC chip. The EC chip's getting hot. So EC chip should get warm when it turns on, but it should not get hot like that. I mean, yeah, that's hot if I'm touching it. So we have a shorted EC chip, it looks like, or that power rail shorted to it. So let's take a look there. I'm guessing we have a shorted EC chip, and I'm guessing that they did something. I don't know exactly how they shorted it out, but let's measure voltage around here real quick. I'm not getting 3 volts over here. 0.06. Okay, here's 3.3 here. That could be a signal. This is going to be the LDO, it should be. You got 3.3 on one side, 0.09 on the other side. What is that? 3.3, 3.3. So this is our 3.3 linear voltage regulator. There's that switch. Yeah, this is bad news. Short EDC chips, pain in the butt to deal with. So I probably have a donor board I can pull one of these off of. I don't think I have any new ones of these. Let's see, this is a Mech 5200. I can look, I have a few EC chips here. Let me check. All right, Super IOs, what do I got? What do I got? Yeah, these are all ENEs. I don't have any Mechs. These are mainly for Alienwares, because the Alienwares, they get corrupted ECs a lot. These XPSs rarely have an EC issue. So, okay, I think we're gonna have to pull the CC chip off of here. And then I'll get a donor board and we'll see if we can get one transferred over. I don't have a stencil for it, but I have some universal stencils, so we'll have to reball it and get one put on, and then we'll continue. Okay, just so I can show you for context here. So here's the customer's original board, and here's a test board that I have that works. And so I just want to show you what the difference is. So here's the EC chip right there. And if I plug in the power, you'll see it get warm. See, it's getting warm, but you see it only gets up to 90. It's just warm. And so it just is doing stuff, and you can see it just stays a little bit warm, but not too hot. And then the CPU turns on. That's the CPU. So that's what it should be doing. Now, when we plug in our board, or we plug in the customer's board, it instantly gets to 120 degrees, and it just keeps getting hotter and hotter. And you see it's on that edge more. It's not even in the middle of the chip as much. So yeah, we definitely have a internal short in that EC chip. So it definitely will need to be replaced. So I'm going to remove this chip, and then we'll see about getting a new one put on there from a donor board. All right, here's a perfect candidate for a donor board. I have one that's, it looks like it was a water spill at some point, and it has a hole in the PCB. So it's the same exact board. We'll go ahead and remove that off of there. And we'll remove that, and then we'll have to re-stencil this, and then we'll get it installed. All right, we'll put a little bit of flux on here. We want to try to get as much flux under here as possible. We don't want to rip any pads when we're getting this off. I'm going to add a little tape to this switch over here. Make sure I have some tweezers that fit it. Yep. And this little rubber thing, I'm going to go ahead and take it off so it doesn't melt. We'll put it back on. All right, I think we're prepared enough. Turn on our air, get our heat going. I'm gonna heat this up enough, and then once I start seeing it move, then we can grab it. And you actually can move chips over, these VGA chips over. If we're doing it from board to board, I can move it over without reballing, and I may end up trying that. That just depends on how well I can get this off the board without messing up the balls underneath. And so basically you're leaving partial balls on the board and partial balls on the chip, and then when they go back together, it's the same amount. Okay, so we got it moving. Is it moving all the way? Good, okay. So I gotta get my tweezers around it real quick. I'm gonna heat it back up. We'll go straight up. All right, so it wasn't perfect. You can see some of those are flat because I didn't have it all the way hot. So we'll see, but we might be able to just reflow that. Yep, let's lay those down. All right, so those actually look pretty good. So let's go ahead and try doing the trick where we move a chip over from a donor board and don't have to reball. So as long as we can get both sides looking like this, we can actually marry them together and it's the right thickness because we're going from board to board. All right, look on the other side, there's a big ball here, but that could be that it collected somewhere. And I can see a couple pads where it left some of the solder on there, but those, it looks okay. They're a little high in those areas, so we have to be weary of that, but when we move over the new chip, we'll see how it goes. These don't need to be programmed on this particular board because the BIOS actually contains the EC region. Whenever you do a CMOS reset where you empty the power from the system and you turn it back on, the system will turn on by itself and then start copying all the EC stuff and programming the chip automatically. So we don't need to program this chip, which is nice. So we should be able to just put one on. So here's our donor board. So this is the most important one to get off properly. We don't want to damage it at all. So we're going to be very careful trying to lift it up perfectly straight after it's thoroughly heated. And I don't care about any of these things on this board, the switch or this little thing, because this is the donor board. You can see it bubbling out, so it's getting close to hot. Okay, so I can see it moving. But I want to get my tweezers on it, so I'm going to let it cool off just for a second. And I'll put my tweezers on there. I'm holding it in place. Now I'm going to reheat this one a little bit longer, and that way I make sure that it's completely melted everywhere. I'm going to pull straight up. Look at that. That's beautiful. So you see how all the balls look perfect underneath? And all the balls look perfect underneath there. That's what we're looking for. So now we should just be able to transfer it straight over. So I'm just going to set the chip down. Same orientation. Put just a little flux underneath here. You don't want too much. We'll rub this around. Once it actually adheres, then we'll add more flux. So this is interesting. Pin 1's marked there, and that pin 1's marked there, but I just pulled this off this board in the exact orientation I just took it off of. And look at this, pin 1's up there. You see that? So this board is a variation, I guess, of the same board. See, I'm glad I paid attention to that. So pin 1's there, pin 1's here on this one. Same chip. Chip number is the same, right? Or did I not even check? MAC 5200 LJ, MAC 5200 LJ. Okay, so we actually need to install this the other way. That's why we always check. That's why we always check. All right, so it's going to go that way. All right, so the way I'm going to do this is I'm going to get it all lined up. I'm just going to hold it in place like this. And those two balls are going to be on top of each other, but we want to get it held perfect. And once I have the lines lined up the way I like it, then I'll bring in the heat. Okay, so I'm going to bring in the heat. Really only get one chance of this, otherwise we have to reball. So, all right. So I got those heated up and let them cool for a second. We're going to get this in the right spot. I'm going to hold that where it goes. Don't move. Hold my breath. And then let it cool off. Okay. So it's tacked in place. We'll add more flux. And then we'll heat again. And it should seat itself whenever it gets to the right spot. Whenever it heats up enough, it will seat itself. Okay, there we go. Did you see it move? Only one side seated. Let's see if we can get this other side to go. There we go. Okay. So I just want to make sure it's thoroughly melted underneath there. Okay. There we go. So there's a chance this won't work because we are doing, we didn't do a reball or anything like that, but I like to do this first because a lot of times it's a lot easier and I can do it in the first try. I've done this many times and I thought it'd be interesting for other people to be able to see this as an option because I know a lot of people are like, oh, you got to reball, but this is always an option. So let's try this out. We'll let this cool off and then we'll plug it in and test. So this is just a silicone pad that I'm going to use to help cool it off a little bit. All right, and then we will clean it with some alcohol. Then we'll cool it off a little bit more. A little air. All right, so we have it back down to a decent temperature. Let's plug it in and see what current we get. It could completely not work at all. We'll see. All right, so keep an eye on the voltmeter. Keep an eye on the power meter. 0.01, that's perfect, and it should turn on by itself. Let's see if it's going to do it. It's not turning on by itself. Let's see. But it's no longer shorted. The power button's over here on this one, so let's see if we can trigger the power on. So here's the power button. We got to figure out which pin is the actual power button. We're looking for a 3.2, 3.0. So there's the 3.2, 3.1, something like that. 0.6. Okay. So this is the only one that's 3.2, and then there's next to it's ground. So we'll just short those together. Did we get anything different happen? So when I press it for a second, you see it goes to 0.02 for a second. Let's do it again. Okay, so it's not posting. It's not even trying to power on. Let's make sure we have our 3.3 at our EC chip. Okay, so we no longer have our 3.3 over here. So that would be an issue. We still have that 0.012, but we don't have 3.3 here. Now there's a chance we have a solder ball that's touching each other in here, and that might be what's going on. Let's check that one. I know that we had 3.3 here before. So we don't have 3.3 in this area at all. Okay, we'll have to take that back off. That was worth a try, and then we'll actually see if we can get this reballed, and then we'll install it again. Actually, I decided I'm just going to reflow this real quick, and then I also want to double check to make sure that I'm correct, that it auto programs itself. Considering we did take this off a board that I thought was the same board model, but I think it's one generation newer or older. And so the layout was a little bit different. So the programming may be different on this chip. And there is a possibility that it does need to be programmed. And so I need to, I'll look into that real quick, because although we aren't getting the 3.3, so I guess that should be conclusive right there. Let's check to see, now that I refloat it, see if we get our 3.3. Okay, we're still not getting 3.3. I'm gonna unplug the charger and plug it in and see if it spikes up for a second. Nope. What about over here? Nope. All right, yeah, let's go ahead and take the chip off. So we'll continue. Okay, well, the balls look good. I mean, there's a couple that when I just pulled it off just now, they weren't touching all the way because I didn't let it heat up all the way, but the balls looked okay. Interesting. Okay, well, let's, we'll reball this anyway, and then we'll continue. Ah, I see something. Might need to check my video here, but I don't know if I just knocked this off just now. See, this is moved over, that's moved over, this one's moved over. I might have just done that, or I did it earlier when I took it off, and that's why it's not working. Because to me, it didn't make sense that it wasn't working. So let me go back and check my footage, and I'll see if this was the issue, because then we could just, I mean, now I'm going to have to reball this because I took this off, but it would make more sense. And there's a ball right there. All right, so I'll be right back. Let me go check my footage. All right, I went back and checked my footage. Yeah, when I just pulled this off, I knocked those, which you would see in the footage. So, but I just wanted to make sure. So we'll have to fix these right here because I'm clumsy. We'll get all this cleaned up here, and then I'll reball this. We'll have to reball this chip right here. We'll have to find a stencil for it. So let's get on that. All right, we got those fixed. All right, let's clean up all this old solder. So I don't want to press down too much. We don't want to ruin these pads, so we're just trying to collect what's there. So I'm actually gonna add some of this solder first. All right, that's looking pretty good. So now we got to get the chip ready. So we'll have to remove all the solder that's on this one and see if we can find a stencil for it. So I'm just going to stick it down like that real quick and see if I can get it to stay. And then we'll see if we can collect this solder off of here. I'm not super skilled at this. I don't have to do this very often, so don't follow my advice on as this being the proper technique for anything. But what I'm doing is I'm trying to remove all the solder that's already on there, and then we'll put fresh solder. That looks good. All right, let's see if we can find a stencil. All right, so I have a few of these universal stencils. So we're just gonna see if we can find one that matches close enough. Well, I'm not really seeing any. Like that one's pretty close, but it's just a little off. This one's the right hole spacing, but it doesn't fill the middle. All right, after going through all my universal stencils, I have bags and bags of these little tiny universal stencils. I finally found something that looks like a pretty good match. It doesn't have the exact pattern, but we'll be able to work with this. So I got some solder paste, and we are going to get these balls installed. Okay, we got to apply even pressure. So let me get a little bit of flux on here, not much. Hold that in place. The solder paste is a little too wet, so I need to figure out what we're going to do about that. You want it to be kind of dry. See how runny it is? I don't want this to move at all. I need to get this staying in the exact same spot. All right, let me see if I can remove the excess. We want to make this as smooth as possible and not have any overflowing. Perfect. Okay, so I'm going to come in slowly with the heat. Did I just move it? Great, okay. Let's go ahead and pop it off. All right, good. So the balls are pretty good. Let's make sure we don't have any of the extra ones on here. Looks like we'll have to fix this one right there. We'll have to add one of these balls on there. And one right there. And one right there. So we will install those real quick. So let's move some of these over. Okay, got one there. I'm just putting flux underneath here to help it stick. That's the only reason why I'm doing that. Okay, so let's take this ball. It's kind of a big one here. Let me see if I can find another one. Where was the last one? I thought there was 3 of them, right? They're right here. All right, let's see if we can get those to seat down in there. Perfect. So now I'm going to add some flux after now that they're seated in there, I want to add some flux so then they can, that will finish getting them completely ready. I'll flood the whole area. But I didn't want to do this ahead of time because I didn't want them running away. All right, we got the chip reballed. So let's go ahead and get it installed. Everything's looking good on that. All right, so we're gonna add just a little bit of flux to the board before we do this. Let's see, okay, so it's gonna be this orientation, you can see the dot. Okay, so I'll hold it in place, we'll heat it up, and we'll see if we can get this thing to seat in there properly. Check to see if it's tacked down a little bit. Okay, it is. So now I can actually move away and we'll just let it seat itself after this. There it goes. Do you see it move? It just seated itself. All right, it's all looking good. So we'll let that cool off. We'll see if this actually fixes the issue. I mean, we may still have to do some sort of programming at this point. The BIOS chip is tied to this EC chip, and the BIOS is what actually has the programming. So we could have kind of a combination of things that happened. That the EC chip got corrupted. I mean, the EC chip shorted out and corrupted the BIOS, so we may have to rewrite the BIOS too, and maybe that's what's going on in the first place. So maybe installing it the first time, the EC chip was working just fine. But we did notice that the 3.3 volt power for this EC chip wasn't coming up like it was before. So we'll figure it out. Let's just get this cooled off real quick. All right, let's go ahead and test it. Keep your eye on the power meter there. Went to 20 volts, 0.09, that's a little high. Okay. 0.12. Oh, we got 1.2 amps. Let's see. And the CPU is getting hot. All right. I think we fixed it. So let's go ahead and let me clean off the CPU and GPU's thermal paste, and we'll put fresh thermal paste on there, and we'll get this reinstalled, and we can test and see if this is actually posting. But right now it looks like it's pulling the right amount of current for it to be starting up. So replacing that EC chip did do the trick. So let me get this cleaned up. All right, let's get this motherboard installed so we can test it. I got fresh thermal paste on here. I'm installing the heat sink. All right, the motherboard is installed. Let's go ahead and plug it in and see if we can get a post. Keep an eye on the power meter right there. All right, I got 20 volts, 0.08. It should come on automatically because when it does a CMOS reset, and we got a Dell screen. It's perfect. Okay, I want to make sure it goes through the whole boot process here because there is a chance that we could still get a Dell screen, but it still won't finish posting. I'm getting a blink code here, which is, let's see if I can show you. So this isn't a blink code. See how fast it's blinking? This is, well, I think technically it's a 4.1, but it's a fast blink code. This is telling me the battery's not plugged in. Right now, I just want to see if I can go through the CMOS reset and we can get it to get to the BIOS so we can access the settings in there and then see if we can run a diagnostic real quick. We're pulling 2.1 amps. It's holding steady. What I want to see is it actually going up and down because I want to know that it's doing something instead of just kind of staying here on the screen. So we're up to 2.4, so it's still crunching some numbers. So it's still doing something good. This is what we want. Eventually, it should actually turn all the way off and then come back on again. Okay, we're down to 1.8, 2.2, 3. So we went 3.4. We're doing good. I think we're about to get past this screen here. All right, so we got this secured with Dell safety BIOS, so now we got our time and date. So let's go ahead and install their battery and their hard drive and see if we can get it to boot up to the operating system. Okay, I got their battery installed. We'll test one thing at a time. The last thing I want is to actually install their hard drive and have it blow out the EC chip again. So let's just make sure the battery's working, and then we'll install their hard drive and see what happens. All right, we got the Dell logo. We got the charge light. How many amps are we pulling? So we're only pulling 1.8. So that's just powering the machine. We're not seeing it actually doing any charge current. If it was doing charge current, it usually is about 3 amps on this machine, so we should jump up to about 5 amps, and then whenever the laptop's running, it will do probably 6 amps or so. This is a 130 watt charger. We're only using 43 watts right now, and so usually when we're maxing out the charger, it goes to about 115 watts. So let's just make sure, I want to make sure it charges the battery still. And I want to make sure that it can boot up to an operating system. And their note says that the SSD that they installed doesn't currently actually have a operating system on it, so we'll use one of our test drives. I'm going to do that first before I plug in their drive, because I want to make sure it boots up and everything works. And then we'll plug in their drive and see if it blows out the EC chip all over again. All right, perfect. So we are pulling a little bit more current, but we don't have charge current yet. So let's go in the BIOS, and I just want to see if the battery is being detected and if it's showing that it's charging the battery or not. The battery's at 99%, so it means that the battery's all the way charged, so that's why it's not charging right now. It is detecting the AC adapter, 130 watts. Battery's at excellent health. Let's unplug it and see if it runs off the battery. And it does. It says discharging. So let me install our test drive, and then we'll go ahead and boot to an operating system, make sure everything works with that. And then we'll plug in their drive and see if it destroys the laptop all over again. All right, I have my test drive with Windows 11 in here. And notice the laptop didn't die with my test drive in there. We are booting up to Windows 11 right now. This will take a minute, so we'll come right back. All right, so we got a blue screen that just says inaccessible boot device. That just means that we don't have the SATA controller settings correct. It's probably on RAID on, and this one was installed with HCI, so we're going to switch that real quick. But good news, it's actually accessing the drive properly, so I'm not too worried about this. We'll just come down here to boot. Oh, wait, go down to storage, and then we just need to change this to AHCI, and then we will save. All right, perfect. It's getting devices ready. Perfect. So we know that the SSD is working. We know that their slot's working. We know that the laptop's working. Now we get to install their hard drive and see if it destroys the laptop all over again, because we may have a bad drive. All right, so we have their NVMe drive here. It is a Western Digital Black. These are actually pretty good drives. Let's keep an eye on the power meter, and we do have the Dell screen already. So it hasn't blown up yet. We got secured with a safe BIOS. And it shut off. Scanning, because it doesn't have an operating system, is going to this, so this is perfect. I'll boot to diagnostics, and we'll run through that real quick. Okay, I'm running diagnostics, and so I got this error here earlier when I was running the diagnostics and saw that the touchpad wasn't working. And I went and I double checked to make sure the connection is actually connected and everything's working fine on that. So, so we got to figure out why the touchpad's not working now. And let's go ahead and do that. All right, the touchpad isn't working, and it's interesting because the way the system's set up is we have one ribbon cable coming to this junction board, and then the keyboard plugs into this junction board, and we have the touchpad plug in this junction board, and then the LED up here. So we know that the keyboard's working, and we know that this LED in the front's working, but we're just not getting the touchpad working. And I went ahead and off camera, I went ahead and tried out another touchpad. The touchpad's not the issue. I reseed this connector here. But here's what I'm looking at. This is what I find kind of interesting. So here's the hard drive that they installed, right? And here's that ribbon cable. And that goes over to the junction board. But what I want to look at is, remember we kind of noticed this? What is that? What is this stuff? This is the power management controller chip. This is the ribbon cable that goes over there. So I'm wondering if somehow, whenever they installed this hard drive, interacted in this area here and maybe shorted out something in this area, or I was going to look for any missing chips would be the other thing that I'd find interesting. So I don't see any missing components, any components being ripped off or anything. But I don't know what this stuff is right there. It almost looks like Coke or something. Let's check the ribbon cable and see what it looks like. It's not dirty in there. And we're making good connection. But see, I'm looking at this capacitor. This resistor right here almost looks blown. Ah, we found it. We found it. Okay. So we missed this because of this, but this is right next to the hard drive. And so they must have had a screwdriver slip or something spill or something in this area. and then it shorted out a component somewhere right here, which blew this trace up, but it also blew up the EC chip. So we replaced the EC chip, that fixed that issue, but now this trace is gone, so we can't, the touchpad's not working. So we're gonna have to get this rebuilt here. Let me pull this off and we'll put it back on later. So let's look closer at this and try to figure out, what do you think happened? That's pretty burnt. What is this stuff? What is that? And I don't know where this trace goes. I don't know what that's for. Let's measure this resistor and see if it's blown. So I'm in continuity mode. I'm just going to measure across here. So it's 100 ohms. So that's probably right. I bet that's a 100 ohm resistor. So whatever this is connected to, this is probably still connected fine. But it definitely got really hot, whatever it was. It goes somewhere inside the board, so we got to figure out where that goes. There's lots of layers. And then this side goes this way and kind of goes into the board too. And look at this. You see that? What is this? It's like this was... I don't know if that's a scrape or a gouge. I'm really not sure how they did this, but whatever it was, they were probably trying to pry with a screwdriver here. Oh yeah, look at this. This whole area has been pried. It's like they were sticking a screwdriver like this, and then it must have touched some components right here and shorted out something. So the hard drive didn't do anything. It was actually the tool they used. But we got to figure out where this goes and see if we can repair it. All right, well, let's see if we can get a measurement on that line, see if it's connected to anything. I'm going to just measure it to ground real quick. So it's measuring nothing. Let's put it in voltage mode, and then we'll plug in the laptop and see if we can get it to, see if there's any voltage on that line. 0.034. We got 13 volts. Wow, it's a 13 volt line. 13 volts coming through here. So this thing definitely got hot. So I'm wondering if something on the other side of this got burned up. I don't think there's any fuses around here. So this is 5 volt. This is a 13 volt rail right here. This is going to be an interesting one. Try to trace this down. I don't have a schematic for this, so I definitely don't have a board view, and that's a bigger issue. If I had a board view, then it would tell me where this is going. So I'm going to have to rely on using a donor board. But the donor board I have is actually a little bit different version. This is a 9720. And I think this is a 9730 possibly. It's a little bit different here. The layout's a little different. So it's hard to actually use this as a reference. And I'll have to go check my stock. I might have a 9720 in stock. But that way I can try to figure out, where that's supposed to go. But we are actually measuring 13 volts on there, which is the main power rail's voltage, it's battery voltage. And, this definitely got hot. The resistor's still working here. I want to see what's on the other side of this board, though. So let's get the board removed real quick. All right, I'm not a very big fan of this design because you have to take the heatsink off because there's screws underneath the heatsink that hold the motherboard in place. So I have to keep taking this heatsink off every time I want to take this board out. The 15-inch version of this, you can just keep the heatsink on the whole time, which is what I like. All right, since I got those two screws out, I'm actually going to put this back on so I don't get the heatsink compound everywhere. All right, we got the motherboard out for a second time. So let's take a look on the other side. So here's where that burn is. Let's take a look on the other side and see if we see anything. So there's Oh, that's funny. I was like, oh, that's flux, because we never cleaned it off all the way because we weren't actually done installing everything. So, so right on the other side of it's right here. We don't see anything else burned. Here's something. So that is a coil or an inductor, and that inductor just is tying current across here. So we need to reattach that. I'm wondering if that has anything to do with it. That's just a bad solder joint, really. That's not even anything they did. I mean, I probably even knocked it off, but I wasn't rough enough on it, so I don't know. So let's reattach that real quick. So I'm just straightening it out just a little bit. We'll add some flux to it, and then we'll just hit it with a soldering iron real quick. Okay, so that's soldered. All right, now that we have that inductor reattached, let me just quickly install it and just see if that fixes the touchpad issue. I won't screw it together all the way. We're just going to try to boot it up just enough. All right, let's see if the touchpad's working now. So the touchpad still is not working. So that didn't fix the issue. So we're gonna have to keep looking around. I'll have to pull this board back out and we'll keep looking at it. All right, so we measured 13 volts on this trace right here that's burned up. And most of the circuitry right here actually goes to this power management chip. And so I think this is all part of the battery charge circuit in this area. It's kind of strange that it's right next to this connector. But if you follow a lot of these traces here, you can see that these all tie into these pins over here, but really none of these are going over here. So what I'm thinking is a lot of this stuff I can actually, let's see if we can ohm it out, figure out where it goes. On this model, it's pretty much impossible to find a board view or a schematic for it, so I just kind of don't even try. I'd rather fix these things without... Okay, here we go. Looks like that connects right here. But anyway, I pretty much try to fix all these boards without schematics because then I don't have to rely on them. A lot of times the board can show you schematics. Board views are useful because then it tells you where pins are, you know, what connects to what. But in this particular case, I don't know if it would help us that much. I think this is still connected. So this is what I'm thinking, okay? Here's what I think the person did. They had a screwdriver like this, and they were prying, and I think the battery was installed. So let's see, the battery is right here, okay? So I'm guessing they went like this, and then they were trying to pry that up, and it slid across, and it touched across here. This is a 13 volt. All this stuff is 13 volts over here, but if you measure over here, it's not 13 volts. And so I'm assuming that some of this stuff is tying either to the 3.3 or to the EC chip or something like that directly. So I'm assuming that someone went like this, boom, 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 and then touched those together and probably shorted this 13 volt to here, which heated this line up because it had so much current going straight to it and then burned out that EC chip. So I think that's the cause. And if we look, you know, I was trying to figure out why this touchpad wouldn't work. I reseated this ribbon cable. We changed out the touchpad to test that. I mean, the only other thing I could do is the junction board. But I'm starting to lean towards it actually still being an EC chip issue. And not that it's bad, but maybe there's a bunch of pins under there, a bunch of balls. And so maybe one of them is not making contact. Because I found a block diagram of a 9500. This is a 9720, so it's a 2022 model. This is for a 9500, which would be the 2020 model of the 15-inch version of this. The boards are completely different, but they use the same EC chip. And if you look how this is actually set up, is you have a PWM for the fan control, and then you have PS2. The touchpad is actually connected to the EC chip. And then you have the keyboard and all that stuff. So we know all the keyboard's working, but the touchpad's not working. And I think that, you know, it could just be like one pin that's just not making contact. So What I want to do next is actually just reflow the EC chip and see if that fixes the issue. So let's go ahead and do that. So, you know, I'm not the best at reballing things, so maybe one of my balls aren't the right size or something like that. So we just want to make sure that we can get this flowed really good. So I'm going to put some extra flux under here. And all we're going to do is heat it up and move it around a little bit and let it seat itself again. So. And hopefully that fixes the issue. Okay, so I'm just gently rocking it around and tapping it. I'm not really pressing down on it too much. I'm just trying to make sure that we can get all that solder to flow. Okay, so there's one pin that's not touching. All right. So there's a chance I might have to pull this thing and reball it again or something like that. I don't really want to have to do that, but you know, I think there's a high likelihood that this is going to be what the issue is and why the touchpad is not working. All right, we got the motherboard partially installed. We're just going to test to see if the touchpad's working here. So, all right, we're in the BIOS and let's see if the touchpad's working. All right, perfect. So it just was just a bad solder joint on that EC chip. So we just reflowed it. That fixed that issue. All right, the next question is, what should we do with this? So what I'm thinking is all we're going to do is I'll just put some new solder mask over this, and that will protect that. I don't think that this thing has broken its connection or anything like that. I think that trace just got really hot when it shorted out to one of these other pads over here. So we'll just put some new solder mask over that, and that should be good. It didn't take much, just a little dab of this solder mask. Put a little bit out here. Okay, so we're just going to dab it on here. Like so. And we'll use the UV curing light. Put that on there. And we'll run it through a couple cycles of 20 seconds, so it's about a minute. Maybe a minute and a half of curing, and then it will be fully cured, and then we can put this laptop back together. I'll run full diagnostics on it, and then we'll get it shipped back. All right, it should be fully cured. Yep, it's hard. All right, let's put our little spacer back on here, a little rubber spacer. Like nothing happened. All right, so we got this one all fixed up. This was actually a pretty interesting one. They changed out their hard drive, and I guess they ended up damaging their motherboard. But when it shorted out that EC chip, we just got that EC chip changed out, and then we had an issue, but it was just because of a bad solder joint. So we got that fixed, and now the laptop's working. I'd love to hear your thoughts on this one, and thanks for watching.
I saved another laptop!